So this is halogenoalkane. Question number 1 says explain why S is the major product of the reaction of but1ene with steam. It's an incomplete question. I'm skipping this question. Complete the reaction scheme to show the mechanism of the reaction of 1-bromobutane with OH minus to produce R. Include all necessary charges, dipoles, lone pairs, and curly arrows, and the structure of R. So, this is your halogen, this is partial negative, this is your carbon, which is partial positive, and this is OH minus. Okay, so so this is going to attack on this carbon, that is partial positive carbon, and afterwards, and also this is your primary halogenoalkane. So it's going to give you like SN2 mechanisms. Okay, क्योंकि for tertiary it gives SN1 mechanism and for primary it gives SN2 mechanism. So then H, then this C, then this CH2, CH2, CH3, or OH is attached and bromine is released in this form. Okay. Set ho gaya ji, and oxygen has lone pair of electrons since it has a negative charge. Okay. Or in this question, they are saying a reaction sequence is shown. You have bromoethane. It's going to react with the nitrile. So it would be giving us propane nitrile. And in reaction 2, it's going to be hydrolyzed to give us carboxylic acid. Or then further, they are going to reduce it. This is carboxylic acid, and if you are going to reduce this carboxylic acid, so you would be having aldehyde, and then further on you will be having like you can say primary alcohol. Okay, so again they are asking complete the diagram to show the mechanism of reaction 1, include all necessary charges. Again they are asking like the dipoles. Okay, so this is partial negative, this is partial positive, and has a negative, like has lone pair of electron, it's going to attack, or is tarah se you will see, and Br negative is removed. That's it. Okay. Uh, so give the name of the type of reaction involved in reaction 3. Reaction 3 is this. This is your reaction 3. Okay.
Reduction.
LiAlH4. Exactly. This is reduction because LiAlH4 is a reducing agent. So this is reduction reaction. Okay. This is related to infrared spectroscopy. We haven't done this. I am going to skip this question. So see this reaction 4 and 5 use the same reagent. Okay, देख लेते हैं. This is reaction 4. This is reaction 5. They are saying that reaction 4 and 5 use the same reagent. Give the reagent and conditions needed for reaction 4. Give the reagent and conditions needed for reaction 4. Okay. So what do you think? Like in reaction 4, what's happening in reaction 4? Your bromine is changing into the OH ion, like OH, that is alcohol basically. What do you think? Hmm? If you remember, I told you that whenever you are going to react this halogenoalkane with aqueous ammonia, or you can say sodium hydroxide aqueous, so sodium hydroxide aqueous would be giving OH negative ion, so there would be a nucleophilic substitution reaction. So I would be writing sodium hydroxide aqueous or heat under reflux. Heat under reflux. And if you would be using sodium hydroxide in ethanol,
And if you would be using sodium hydroxide in ethanol, so there would be an elimination reaction, like in reaction 5. Give the conditions needed for reaction 5. So sodium hydroxide, you can say in ethanol, sodium hydroxide in ethanol. Okay. Under appropriate conditions, ethanol and propanoic acid undergo a condensation reaction. State the condition necessary for the reaction. So they are talking about like esterification. Whenever your alcohol is going to react with carboxylic acid, whenever your alcohol is going to react with carboxylic acid, so they are going to form esters. So this is known as condensation reaction. Okay, this is known as condensation reaction, and also this is known as esterification reaction, the same thing. Okay, but we haven't done ester, so I'm going to skip this question. We are only you can say uh, doing related to haloalkanes. Draw the skeletal formula of the organic product. No, see this. V reacts with acidified manganate ions in two different ways depending on the conditions as shown in the reaction sequence below. V decolorizes bromine water. When the acidified manganate is hot and concentrated, propanoic acid is the only organic product. When the acidified manganate is cold and dilute, the organic product is T, which has two chiral centers. Which has two chiral centers. Give the structural formula of V and T. Give the structural formula of V and T. So in V, they have reacted with hot concentrated MnO4 minus. So it has produced carboxylic acid. Okay, carboxylic acid. So what should be the structure of V? What should be the structure of V? So you have to think about it and keeping in mind कि किन किन तरीकों से carboxylic acid we can produce. So the first one is whenever we have primary alcohol, we can make it, we can convert this into carboxylic acid. Whenever we have aldehyde, we can convert into carboxylic acid. Or whenever we have alkene, so we can also convert this into like carboxylic acid. So we have multiple ways. So now we have to think. uh, they have given us some statements that when acidified manganate is hot and concentrated, propanoic acid is the only product, only organic product. When the acidified manganate is cold, okay, and dilute, the organic product is T, which has two chiral centers. Give the structural formulae of V and T. Yes. Do you have any idea? Okay, what should be the structure of this V? हाँ जी, क्या कहते हो? सोचो, 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 सोचो. So V is going to react with hot and the cold. It seems like that this is an alkene. It seems like that this is an alkene. Yes or no? It seems like
So is
that
it
this
an
is an
aldehyde?
alkene. Aldehyde will not react with cold and dilute MnO4 minus. Aldehyde would not react with this.
P is propene.
Propene is this C, then C, then C. This is your propene. Okay. So अगर तुम इसका रिएक्शन करवाते हो तो ये बॉन्ड यहां से ब्रेक डाउन होगा. This is going to give you CO2 and water. I have told you the different cases. When the carbon has two hydrogen atoms, so upon oxidation, it would be giving us carbon dioxide and water. And whenever you have one hydrogen and one R group, in this condition, you have one hydrogen and one R group. So this part is going to give you first aldehyde with two carbon atoms and carboxylic acid with two carbon atoms, means to say okay, it would be giving you ethanoic acid, but this is propanoic acid. This is propanoic acid. Then what do you think?
So butene.
Butene. Okay, let's try butene. Let's suppose we have this is butene. One, two, 3, 4. Okay, or let's suppose this is the double bond over there. So they are saying is the only organic product, is the only organic product. This is very important thing for you, very important thing for you. Okay, they are saying V reacts with acidified manganate ions in two different ways depending upon the conditions. So when the acidified manganate, and also they are saying V decolorizes bromine water. So 100%, this is an alkene because alkene decolorizes bromine water. Okay, and then propanoic acid is the only product. So means that, let's suppose you were saying that sir this is butene. तो अगर मैं इसका reaction करवाता हूँ, so this bond would be breaking down. Okay, this portion would be giving you carbon dioxide and water. Okay, and this portion would be giving you propanoic acid. This portion would be giving you propanoic acid. Okay, so this should not be the answer because it's going to give us carbon dioxide as well. But in the question what they are saying, propanoic acid is the only organic product. So according to this condition, I'm supposed to draw this structure. See this: 1, 2, 3, 4, 5, 6. I'm going to write double bond over there. So if you are going to oxidize this with hot KMnO4, so this portion would be giving you propanoic acid, and this portion would also be giving you propanoic acid. So after reading this statement, I get to know that okay, I should draw this structure in which I would only be getting alkene, only be getting like propanoic acid. If you have left hand side, if you have right hand side, so the both sides are going to give you only one product, that is propanoic acid. So V is CH3 CH2 CH2 CH3. And for T, if you are going to do react with cold MnO4, so I told you that diol would be formed. Diol means CH3, CH2, CH, then OH, then CH, and then OH, or then CH2 and then CH3. So after the reaction with cold acidified KMnO4, so the diol would be formed. तो आपने इस तरह से सोचना है, देखो quite tricky questions basically in which all the things are involved. It's not about the halogenoalkane. When you would be doing remaining papers, remaining chapters, so you will see the previous concept would be coming along with this. So you must know each and everything: alkene, alkane, alcohols, whatever the reaction is. So you need to know. Identify the types of stereoisomerism shown by V and T. अच्छा, दूसरा देखो आपने इसमें क्या कहता है, which has two chiral centers, how? If you can see this carbon, and this carbon, so this is your chiral center. क्यों? I told you chiral center is the one which in which is attached with the four different groups, which is attached with four different groups. That's the chiral center basically. Okay, so basically it's going to give us two chiral centers. So and then identify the types of stereoisomerism. So I would be writing that V is going to have double bond, so it's gonna give us geometrical isomerism, and this T would be giving, you can say, optical isomerism. Optical isomerism. When you have a chiral center, so optical. When you have double bond, so this would be giving geometrical, which is also known as cis trans isomerism. So ये दोनों में difference है. लेकिन remember, I told you that there are two conditions, not only the double bond, but you must have different groups attached with the double bonded carbon. You must have different groups attached with the double bonded carbon. So if you can see over there कि इसमें हाइड्रोजन है और हाइड्रोजन है, so this is different, this is different, this is different, this is different with the double bonded carbon. So yes, it's going to give us optical, like sorry, geometrical isomerism. If you can see, this is this compound कि जिसमें H H CH3 CH3, so same. So ये आपको cis trans isomer नहीं देगा. It won't give you the geometrical isomerism. So remember, there are two conditions: the double bond, and also different groups should be attached with the double bonded carbon. Then I can say it would be giving us like cis trans isomerism. Okay. तो साइड बाय साइड ये भी आपको पता होना चाहिए, लाजमी 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 याद रखना. And then in question number 4, some reactions involve ethanol are shown. Okay, give an equation for reaction 2, including the reagent needed for the conversion. तो reaction 2 में क्या कहता है? Alcohol to chlorine. So I have CH3CH2OH. It's going to react with PCl3. It's gonna give CH3CH2ClNH3PO3. चाहो तो you can use PCl5, चाहो तो you can use SOCl2. They all are going to substitute this OH by chlorine. State the reagent and condition for reaction 1. Reaction 1 में क्या हो रहा है? So reaction 1 means that your chlorine is going to substitute by OH. Your chlorine is going to substitute by this OH. So I'm supposed to use sodium hydroxide aqueous, and we are supposed to provide heat. Okay, identify the organic product X. Identify the organic product X. Remember, okay, this is haloalkane, just like that. Okay, this is your chlorine, then hydrogen, 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 hydrogen. This is base. It's going to react with this molecule. So NaOH in ethanol, this Na would react with this Cl, and this OH would react with this H. So as a result, HCl would be removed. As a result, HCl would be removed. So you would be getting your alkene. You would be getting your alkene. So what is this? This is ethene. This is what? This is ethene. So whenever your haloalkane is going to react with the sodium hydroxide and the solvent is ethanol, so remember there would be an acid base reaction. So as a result, alkene would be produced. And then they are saying nitric acid is added to the products of reaction of this and this in ethanol. Silver nitrate solution is then added to the mixture. What you would observe? I told you the two reactions, like the test for halide ions. Okay, like you can say, if you are going to add silver nitrate to the chloride, then it would be giving us white precipitate. And you can say if you are going to add silver nitrate into the bromide ion, it would be giving us cream precipitate, or for iodide, it would be giving you yellow precipitate. So, in this reaction, HCl is NaCl is produced, and also the water is produced. Okay, because your sodium has reacted with this chlorine to make sodium chloride. or your OH is reacted with this H to form this water molecule. So they are saying कि if nitric acid is added in the products of this reaction, so ultimately कि you are going to add nitric acid in this and this. So of course your nitric acid would be reacting with this chlorine. और ये आपको क्या दे रहा होगा? White PPT, white precipitates due to the formation of silver chloride. Write an ionic equation including state symbols for the reaction responsible for observation in part 2. So as you know that I told you, okay, silver chloride is for white PPT, silver bromide is for cream PPT, and silver iodide is for yellow PPT. So silver chloride solid can be formed by the reaction of Ag positive ion or Cl negative ion. This is an ionic equation. Identify the organic product Y which is distilled out of the reaction mixture. भाई Y क्या है ये? तो Y को देखिएगा जरा कि what is Y? In Y they are saying your primary alcohol is going to react with oxidizing agent, that is K2Cr2O7 potassium dichromate, which is which is orange in color, and after the reaction it would be changing its color into green, orange to green. But I told you, you have to look into the conditions, because there are two conditions for this reaction. Sometime examiner uses heat under reflux. So you know what would be your final product? Carboxylic acid. But in this question, उसने क्या कहा? Distilled off. उसने क्या कहा? Distilled off. Distilled means, distillation means कि once the aldehyde is produced, so you have separated the product. So name the organic product Y. So I would say that this would be your ethanol, which is aldehyde. Okay, this would be ethanol, which is aldehyde. Explain in terms of the properties of an intermolecular forces in CH3, CH2, OH, and Y. Why the chosen conditions for the reaction ensure that Y is the product? Explain in terms of the properties and intermolecular forces in CH3, CH2OH, and Y, like they are comparing this aldehyde with this primary alcohol. Why the chosen conditions for the reaction ensure that Y is the product? क्या कहते हो कि कंडीशन इंश्योर कर रही है कि भाई Y would be the product, मतलब what you would be writing in this question? क्या कहते हो? हाँ जी, any idea? Any idea that your primary alcohol is going to convert into aldehyde and it is making sure that no carboxylic acid
Should get
would be
distilled off
produced?
after it has formed an aldehyde.
Basically, this is of 3 marks. You know, you must use the key points. Let me show you the marking scheme. It's question number 4. Okay, so and can you tell me like what type of intermolecular forces alcohol has, and what type of, obviously we haven't discussed aldehyde yet, so ultimately I'm not asking what type of intermolecular forces in aldehyde, but see this in question number 4. They are saying CH3 CH2OH has higher boiling point than this CH3 CHO. You know, alcohol has higher boiling point than aldehyde due to hydrogen bonding. If you remember, when we were discussing the chemical properties of alcohols, I told you that alcohol is going to make hydrogen bond. Due to this property, it has high boiling point and it has excellent solubility in water. We use a special word for this, that is called miscible. Miscible means maximum solubility in water, or strong intermolecular forces हैं, strong intermolecular forces हैं, which is going to prevent further oxidation, which is going to prevent further oxidation, remember. So since your alcohol has higher boiling point And obviously, why this is having higher boiling point? Due to the stronger intermolecular forces, or due to stronger intermolecular forces. So like obviously we can say that के, and also आपने उसको distilled off भी कर लिया था वहां से, तो that's why this property is making sure that due to stronger intermolecular forces of attraction, okay, so it could not be converting into the carboxylic acid basically. Okay, so you must mention that your alcohol, that is in this case ethanol, has hydrogen bonding, and obviously due to this it has strong intermolecular forces of attraction. Okay, strong intermolecular forces of attraction, or due to this it is preventing further oxidation basically, क्योंकि आपने उसे वहां से क्या कर लिया, डिस्टिल्ड ऑफ. आपने अगर डिस्टिल्ड ऑफ नहीं करते, ऑब्वियसली यू आर प्रोवाइडिंग then key, like you can say continuous heating, that is called heat under reflux. So automatically you would not be getting aldehyde, balki your final product would be like carboxylic acid, simple. Okay, और दिस इज रिलेटेड टू एंथैल्पी चेंज, अभी मैं इसको छोड़ रहा हूँ. और ये भी दिस इज रिलेटेड टू फ्री रेडिकल सब्स्टिट्यूशन रिएक्शन, इसको स्किप कर रहे हैं हम. Yes, this is good question. Chloroethane can be converted back into ethane by a two-stage process via an intermediate compound X. Give the name of X. Give the name of X. What do you think? कि भाई क्या है ये? What is X? कि ये convert हो रहा है. Your haloalkane is converting into ethane, simple alkane, and this is your intermediate. Give the name of X. Give the name of X. Yes. What do you think? What should be
Sir,
X?
ethene.
Ethene. अच्छा जी, ओके, नाइस. क्योंकि क्योंकि अगर ये कंपाउंड Cl then H then H then H then H then H, so first of all आपने इसका रिएक्शन करवाया होगा सोडियम हाइड्रोक्साइड इन एथेनॉल से, this and this would be removed and alkene is produced, and then in reaction 2 you did hydrogenation in the presence of hydrogen and nickel catalyst, so you got your alkane. So the intermediate is ethene. Suggest the reagent and conditions for reaction 1. So I would say sodium hydroxide in ethanol and heat under reflux. Okay, and heat under reflux. Or suggest the reagent and conditions for reaction 2, hydrogen and nickel and 200 degrees Celsius temperature. So your alkene would be converting into alkane. It's very simple. Okay. Or the halogens and their compounds have a wide variety of uses, and the chemical and physical properties of the elements, okay, show regular patterns related to their positions in group 7. Give the structures of the four structural isomers of C4H9Br and identify each as primary, secondary और टर्शरी. ट्राई करो, फिर मैं बताता हूँ. यू आर सपोज टू मैच. ट्राई करो आप लोग फटाफट जल्दी से, फिर मैं बताता हूँ. जल्दी 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 फटाफट. चलो जी, मैं भी बनाता हूँ, आप जरा देखिएगा. यू आर सपोज टू मैच कि कहाँ तक यू आर राइट. So I have four carbon atoms. Okay. So I would be drawing the primary halogenoalkane first. The primary halogenoalkane first. Okay. Or then uh, I'm going to write the मैं हाइड्रोजन नहीं ड्रॉ कर रहा यार. This is your secondary halogenoalkane. Okay. And this is your tertiary halogenoalkane. Okay. Or, and what should be the another possibility? है भाई, what should be the another possibility? So I can draw, I can draw this. So to make sure that you are drawing the right one, the best way is to give the name. The best way is to give the name. Okay. So the first one is 1-bromobutane, 2-bromobutane, 2-methyl, 2-bromo, 2-methyl propane. Okay. And 1-bromo, 2-methyl propane. So सबके नाम different हैं. So yes, they are isomers. Isomers are possible. When the name is same, so the isomer is not possible. But when the name is different, so the isomer is possible. Simple hai, very simple. Name the isomer of C4H9Br that contains a chiral center and draw the three-dimensional structures of the two optical isomer. So you are supposed to decide which is going to give you a chiral center. क्या कहते हो? 1, 2, 3, 4. Which structure is going to give us optical isomerism? Obviously, the one which is having a chiral center. Obviously, which is having a chiral center.
Sir, 2-bromobutane.
Exactly. Good हो गया जी, good हो गया. So this is 2-bromobutane. So the structure would be कुछ इस तरह से. This is bromine. O H and this. Okay हो गया. Then I'm going to draw the mirror image. Mirror image क्या होगा? लेफ्ट का राइट, राइट का लेफ्ट, लेफ्ट का राइट, राइट का लेफ्ट. So that would be the mirror image of this. This is a 3 marks. Oh भाई. Okay. So this is again related to the cream precipitate or ye. It's very easy. I'm going to skip this question. So give the full name of the mechanism for the reaction between aqueous sodium hydroxide and bromomethane. Ultimately, जब आपका bromomethane, that is BrNH is going to react with sodium hydroxide, uh, bromoethane. Okay, 2 carbon atoms. So it would be giving you OH, है ना? OH. That would be the type of reaction would be nucleophilic substitution. Nucleophilic substitution. Why? Because negative is going to replace the negative ion. That's why this is uh, nucleophilic substitution reaction. Okay.
सर इसमें
और
बायोमोलिक्यूलर मेंशन नहीं करेंगे?
नहीं SN1 और SN2 मेंशन नहीं करेंगे. नो. बस कह दो कि न्यूक्लियोफिलिक, जनरलाइज कर देना। वैसे है इसमें SN2 रिएक्शन, बिकॉज ये प्राइमरी हेलोजिनो एल्केन है। और पार्शियल नेगेटिव, पार्शियल पॉजिटिव, उसके ऊपर इस तरह से खत्म, सिंपल है। ओके, state a property of CFC which makes them suitable for use as refrigerants। क्या कहते हो? यस, हाँ भाई। हम्म State the damaging effect of CFCs। If you remember, I told you the equation, है ना? I told you equation, जिसमें your ozone was reacting with the chlorine radical, if you remember, है ना? First of all, I told you that your chlorofluorocarbon has fluorine and chlorine both. Since the bond of carbon and fluorine is stronger, it's not gonna break down easily in the presence of UV light or sunlight, I can say. So ultimately, the carbon and chlorine bond would be breaking down and would be giving you chlorine radical. Since the chlorine radical is very reactive, so it's going to react with ozone, है ना? It's going to react with ozone, and then it would be giving you. Let me show you the work that we did for this. So yes. तो the ये था वो। Okay. So basically, disadvantages of CFC: retain for a long time in upper atmosphere, or मतलब के this bond is gonna break down and then it would be reacting with ozone. Finally, it would be giving you oxygen gas. Finally, your ozone has been broken down into the oxygen. Okay. और एडवांटेज ऑल्टरनेटिव्स इसका ऑब्वियसली HFCs हैं, LPGs हैं, एंड ऑल्सो खैर ये तो एक अलग ही चीज है। सो दे आर आस्किंग द सेम थिंग, दैट damaging effect, and then explain your answer. Ultimately you would be writing down the equations, that's it। okay जी। तो I'm going, you have this, so this is the last question that we are going to do, okay? So this is your main uh, compound, this is your product, this is your product, this is your product. Can you tell me what is reaction 1, 2, and then 3? And you're supposed to write down the reagents and conditions. First of all, can you tell me what is reaction number 1?
Sir, nucleophilic substitution with aqueous NaOH.
Sodium hydroxide in aqueous. Okay. And heat under reflux. Good. And what is reaction 2? Hmm?
Substitution with ammonia and ethanol.
Okay. Substitution in ethanol.
Substitution with ammonia and ethanol.
Good. In ethanol. And what is reaction 3?
Elimination.
Elimination. So what am I supposed to use?
NaOH and ethanol.
Good. गुड हो गया, इन एथेनॉल। ओके, बहुत इजी बेबी क्वेश्चन है, बेबी क्वेश्चन। So we are supposed to do paper 1 as well, it's quite tricky paper 1. So I have sent you the book, okay, and then we would be starting like the carbonyl compounds, okay, and then the last chapter would be carboxylic acid and ester.